check, okay, through the transformation. If the transformation, original transformation here, we have a doublet of the source, okay, source is the strength is m, right? 如果说我们 source 以前的用的符号是 m， 对不对？然后经过这个转换的时候，我们这 m 会不会要改变？ This m, the strength of source should be changed or not? Okay, that's a question we would like to ask. Okay, so we do that. Okay, we just this is W prime. W is the complete velocity. We take the closed loop integral of the complete velocity, and complete velocity definition is U minus IV, right? This is, and dz is dx plus I dy. If you multiply these two and then just try to find the real part and imaginary part, it will look like this. Okay, and we copy that this one to here. As you can see, this is what? This is U dot U times its okay, along the U direction distance, and this is V times along the V direction, Y direction distance. So this is give us what? U dot dl, right? This is the dot mean tangent. This velocity take a tangential to this vector and multiply with this length, right? So this one, the real part of here will be equal to this. And what is imaginary part of this? U times dy. U times dy is, if you're using this, U times dy is the U dy is here, right? This is our length, okay? And this dl, and dl can be have this dy and dx here. And this is our dy. So U times dy give you the flow across this boundary, flow out, right? And V times dx is what? V times dx is V is upward times this dx give you what? The flow into this, okay, boundary. So into this boundary we get a negative sign here, and out of boundary with the positive sign here. So this give you what? This give you the normal to the, okay, surface, right? Velocity dot n, U dot n, okay, that give you the velocity normal to this surface direction. That means that your flow across this boundary. Okay, so here if you do the U dot L closed loop, what's this definition for this? This is our what? Original circulation, right? So this is circulation gamma definition, 对不对？我们 circulation 的意思就是对一个环状做它的 tangential 方向的线积分，对不对？ And what's this? U dot n. U dot n give you what? The closed boundary, and this give you the volume flow rate, right? And volume flow rate is equal to what? It's equal to our source strength. So m is our source strength. Okay, 我们以前所学的 source 的那个强度 ，okay， 这是我们的 source strength of source. So as you can see, if you do this, it will be real part is our circulation, imaginary part is our source of strength, right? Strength of source. Okay, so we have in the z plane we have the circulation gamma z plus I. Okay, source strength is the mz. That will be equal to this closed loop integral of our compass velocity wz dz. So that according to all this evaluation give you this. And I can change, okay, this wz is equal to df dz, right? So dz and dz is cancelled. So this will give you df, right? And this df, since this is df already, so original we have a cz closed loop. Through the transformation, this cz will be transformed to another plane called the zeta plane. This zeta plane also form the closed loop, so-called c zeta. So we can do the c zeta plane closed loop, and this become df d zeta times d zeta. This will be cancelled again. Okay, so this df d zeta become compass velocity in zeta plane, right? And this again I'm using this relationship, right? This relationship, this become real part is our circulation in zeta plane. Imaginary part is our source of strength of source in zeta plane. So if you compare these two, you will find circulation in z plane will be equal to circulation in zeta plane. Source or sink strength will be equal to, okay, in z plane will be equal to source or strength of sink in zeta plane. So all this singularity, okay, variable strength will not change. We don't have to be scaled. So the strength of the source and sink, all this vortex, okay, are invariant. That means it's unchanged. under the conformal transformation. That's the concurrent we have. OK， 所以经过这些转换，我们不需要去改变什么 mu 的大小啊，这些 W 的大小都不用改变。OK， that's a good thing, right? Otherwise, we have run into a lot of difficulty, right? Okay, so that will be conclude. Okay, for here, I think everything is conclude here. Okay, so this is our mapping through this mapping function, right? And we have the original. We have this. Okay, carbon equation, and this carbon equation also satisfies in zeta plane except this. Okay, that's the critical point. Okay, and compressive potential Fz. This is compressive potential Fz. We can return the compressive potential Fz. Okay, for this compressed body, this is very compressed body in Z plane can be formed by, if you know this, if the transformation from this is this compressed geometry transform to zeta plane become simple one, like a flow over a cylinder, right? And flow over a cylinder we can return very easily. How this flow over cylinder, the compressed potential in zeta plane. So compressed potential in zeta plane Fz can be written very easily because we have all this backseat flow we already have. So simple body is known, okay, already known. So if we know that, and we also know this mapping function, so this Fz can be get what? By substitute this zeta equal to f function of z into our f zeta. So just this zeta equal to the into this will give you the Fz. Okay, this is Fz represent the flow over a more complicated, okay, more complex velocity flow field. Okay, that's the basic idea, basic spirit, okay, of this mapping. We like to using very simple geometry flow pattern, and through the mapping we can have more complicated. OK， 经过这个转换，我们可以得到一个什么比较复杂的流场。OK，that's all the basic. OK, through the mathematics. OK, the rest of here I just mentioned. I don't want to emphasize again. OK, this is all written according to through the mapping. What will change? Why the length will change? The velocity will change. OK, the angle will change. However, the relative angle beta 1 and beta 2 will be keep. OK. All the singularity of so single W circulation are invariant. Okay, will not change. Okay, so that's all. That's kind of give you the conclusion for. Okay, basic concept of conformal mapping. Okay, and here we have additional. Okay, additional is not in our textbook, but in some of textbook it's called the circulation theory. OK， 这个是一个我们在课本上面没讲过，我觉得非常好用。OK， 我们这边讲一下，什么叫 circulation theory? What's a circulation theory? Not circulation, sorry, circular theory. OK, so circular theory gives us what? If you have Fz, it's a compressed potential for the flow. OK, for basic flow, and this is compressed potential of the flow. There's no singularity, or no singularity and no grid boundary. Okay, only a very simple, like a potential basic flow. So if you want to using this, from this very simple potential flow, a circular cylinder can be introduced inside this flow field. 如果说我们要在这个流场上面，我们有一个 simple flow. Once we have simple flow, very simple, like a source or sink, anyway, or uniform flow. Later I will say. Okay, we would like to introduce a circular cylinder inside this flow field. What should we do? We can use this. Okay, the compressed potential will be equal to our this simple flow, simple compressed potential. Okay, and then this simple compressed potential take plus of F bar A squared over Z. Additional term here. Okay, and that will give you the flow over this kind of basic flow over a cylinder. I think I have to clarify a little bit. This is not mapping function anymore. Okay, 这不是 mapping function. 我们刚刚讲这个 small f is a mapping function, right? But here is not. Here just represent this. Okay, a very simple basic complex potential function. Okay, I would like to clarify here. Okay. How to prove? 如果说我们有一个简单的 basic flow， 我们要把一个 cylinder 放在这个 basic flow 里面，我们只要做这样子，就代表我们已经把一个 cylinder 放进去了，流体流过这个 cylinder 已经放进去。Okay, how to prove this? This is called the circular theorem. Okay, so this bar is so-called a complex conjugate, right? 这是我们叫我忘记数学叫什么共轭复数。Right, 共轭复数. In Chinese, this F bar mean is a complex conjugate. Okay, and I will show you later what's the definition of complex conjugate. So remember, okay, this is a function fz. Take the complex conjugate of the everything here will be give you equal to our this function complex conjugate, and the argument here is also complex conjugate. Okay, so this if you have this complex conjugate of everything here, will be have an argument here. 你里面的这些变数或者是复数，它也要变成共轭复数。This function also have to be. Okay, this is the. Okay. Let's example here. If fz is equal to uz is potential minus I alpha. Okay, 这是它的这个 function. This is a function. So what's f bar z? This f bar here, f bar z. F bar z is only change what? It's only change this function here, the complex conjugate of this function. However, I didn't change z, so I keep the z the same. However, when I find this exponential minus I alpha, become what? Become positive sine I alpha, right? That's a complex conjugate, right? So this is just change the imaginary part sign, right? This is a complex conjugate. So this is minus sign become positive sign here, okay? Okay, so this will give you this. Okay, however, if you change the z to z prime, z bar here. Okay, so this z will be changed to z bar here, right? This is the original z. Since our argument is changed, 我们变数已经改成 z bar, 所以this z will be changed to z bar here. Okay, and as you remember, I just mentioned f bar over z bar will be equal to fz bar, right? So this is f bar z bar is equal to this, will be give you the fz bar here. Okay, so we have all these basic kind of mathematics. Okay, so let's say if we have a circle. 假如我们现在有一个圆 how do you represent the circle formula? Circle formula you give you this absolute value of z is equal to a, right? 这就是代表什么？这个 this z is represent a circle, right? Because all the length is the distance is from original is the same. So this is our radius, okay? And this represent is a circle, okay? So if you do that, if this is circle, so if you're using this a square will be given the z, this z square, absolute value of z square, and this absolute value of z square can be written as z times z complex conjugate, right? So z times z bar, so z times z bar gives you z square, and what's the z bar here? Okay. As you can see here, the z times z bar equal to a square. So z bar is equal to a square over z, right? A square over z. Okay, a square over z. So if you're using this, as you can see here, this is our circular theorem. Okay, the complex potential. If you introduce a circular cylinder into our flow field, the complex potential will look like this. Okay, so Fz and F bar a square over z. A square over z, according to this formula, if a circular cylinder here, our z bar is equal to what? Is z bar equal to a square over z, right? So this a square over z is equal to z bar. Okay, and this F bar here. Okay, so become F bar and Z bar. F bar, Z bar give you what? F bar, Z bar give you the FZ bar here. So this is FZ bar here. Right? And what does this mean? This is a complex function plus its own complex conjugate. 什么意思？一个复数加上它的共轭复数变成是一个实数，一个 FZ is equal to a plus iv, right? FZ bar is what? A minus iv, right? If you summation these two together, This will be cancelled. Right? So that's only real part. 只剩下10步 Right? So this is real. This is real. Right? This is only real part. And this is complete what? Complete potential, right? And complete potential is composed by what? Real part is what? Velocity potential plus I psi, right? Psi is what? Stream function, right? So stream function for this is what? Stream function is equal to 0. On what? On the circular cylinder here. So this is circular cylinder. This is our circle. So on the circle, we find that on the circle is one of string line. That means we already introduced a circle into the flow field. Right? That's how they prove. So circle is a string line. Z equal to A is a string line. Okay? So when we do that, we will introduce a circle into the flow field. Okay, let me show you the example, much easier. Okay, if you have uniform flow, this is uniform flow, right? UZ is our uniform flow. If you insert the circular cylinder with a radius A into this uniform flow, by applying the circular theorem, circle theorem. So this is UZ. And F prime, what? F bar is what? Because we don't have any complete conjugate for here, right? Because it only changes what? U times what? When you replace Z, become A squared over Z. So this Z become A squared over Z. So that gives you the flow over a circular cylinder. That's the same as our previous example, right? Previous example is what? It's a uniform flow plus a double flow, right? 我们把一个流场加上一个所谓的 double flow give you this. So this is supercomposed uniform flow with a double flow with a strength use A squared. Another thing is, okay, if you have angle attack flow, this is a uniform flow with angle attack. Okay, is Fz is U is potential minus I alpha Z. They give you the flow field like this. This is flow field like this. Okay, flow field like this. And I would like to introduce a circular cylinder inside this flow field. What should I do? I apply this circle theorem. This is circle theorem, right? So it's the same at the this Fz is equal to this. So this is the first term here. The second term here, what happened? Because I have to do the complete conjugate of this. So for complete conjugate of this is become part sign here. U is potential I alpha. However, this Z should be changed to this. So U is potential I alpha, and Z changed to A squared over Z. So just summation these two. Okay, just give you the flow over circular cylinder with angle attack. So that will be sign of that. I just give you this formula here. So this is a uniform flow with angle attack, and this is what? This is a doublet. However, W rotate angle alpha here. Okay, so this one plus this one will give you this. Okay, so you have to change here. So these two plus together will give this flow here. So flow over the cylinder with what? With angle attack. Okay, by applying the circular theorem. Very easy, right? Finally, if you have a sink at the Z x equal to L. 如果你有一个简单的 sink flow, okay, at this location, so our complex potential will be like this. Right? Mass m is represent the sink over m, and natural log z minus L. L is our sink location. Okay, m is our strength. Okay, so if we want to introduce a circular cylinder into this flow field, what happened? We apply the circle theorem here. This is first term here. And second term here, as you can see, F prime, right, F bar here. And this F bar, what happened here? Do you know the natural log? When we do the natural log, when you do the complete conjugate natural log, what happened? We can prove that. You can see this is the natural log of Z, right? It's equal to this. Okay, and natural log of Z bar is RE minus IC that because it is IC that is minus IC becomes Z bar here. So become like this. So if you do the complete conjugate of everything here, become the natural log of this, right? And natural log of this will be equal to this. And you compare these two, what happened? Natural log Z will be equal to natural log bar of Z, right? So this should be equal. So if you do the complete conjugate of this, will not change, right? So here the second term here only change is what? Z replaced by a squared over Z, a squared over Z minus L. So we didn't change anything, just only Z is a change. Okay. Finally, okay, if you do that, you can see I have these two terms here. If I kind of rearrange this formula, natural log Z, these two terms, and this natural log Z can be separated by, this one can be separated by this, okay? And natural log A times B will give you natural log A plus or A minus this, right? Because this is this term here, okay? And this is second term here. Okay, and we have one additional term here. Okay， 对不对？应该对。Okay. So as you can see, if you separate, this is constant. So everything here is constant. So this is what? This is our sink, original sink at this point, right? And here we introduce a source here. Source is the origin. And here we also introduce a sink at this location, and this location, Z equal to a squared over Z. So when you have the original, we have only this sink. And then when you introduce the additional here, and the constant here, you will form the circular cylinder here. So flow pattern will look like this. Okay, this is all sink flow. May not be correct. I'm sorry. This since I cannot find, this is a similar pattern. Okay, this is a source here, and then when you introduce a source here, and then if you have a single source, try to introduce the circular cylinder, it will be like this. A sink, I don't know. Sink should be slightly different. Okay, since I cannot find any flow pattern similar like this, this is just give you an example. Okay, this is in this figure here is a source here, and this is sink, so similar. Okay, if you introduce a source and sink inside this circular cylinder, you will form a flow over a circular cylinder inside this flow field. Okay, I think I will stop here. Okay, this is a kind of the end of this chapter 4, not the end of chapter 4. We still have the component B. Okay. Okay, so next Tuesday we have a midterm. Okay, try to prepare. Okay.